It's a lesson on ratios and rates, and let's first talk about a ratio. A ratio, what it does is it compares two numbers or quantities by division. And there's actually two types of ratios. The first is what we would call a part-to-part ratio. And just to clarify what that means, let's say we were talking about boys and girls in a classroom, and there were 12 boys to 8 girls. So a part-to-part ratio would say that there's 12 boys to 8 girls, and then we would actually simplify that ratio since it has a common factor of 4. So that's actually a 3-to-2 ratio. So you don't actually use units, but I will just in this case, just to illustrate what that 3-to-2 means. That means there's 3 boys for every 2 girls in that classroom. So you could write that as 3-to-2. You could use a colon, or you could use the word 2. So there's 3 ways you could write that part-to-part ratio. Now let's say that we were going to use those same numbers there, that same relationship, to talk about what the other type of ratio, which is a part-to-whole ratio. And that's where you, for example, if we were talking about the ratio of boys to total students in that classroom, so if we were talking about boys to total students in that classroom, we would need to do what's called a part-to-whole ratio. So part-to-whole means I have the part, so in this case it'd be boys to the sum of boys and girls, which would be total students. So in this case it would be 12 over 12 plus 8, which equals 12 over 20. Now the common factor is again 4, so that's a ratio of 3 to 5. Now the ratio of girls to total students is 8 to 20, which we know, let me clean that up a little bit, 8 to 20, which simplifies to 2 parts to 5. So that's different types of, we use all the same relationships there, boys to girls in a classroom, to come out to talk about the 2 different types of ratio, part-to-part and part-to-whole. Now let's do some problem solving with ratios. And so let's look at this first problem. So Jan's flower garden has only daffodils and tulips in it. There are 15 daffodils and 12 tulips. What is the ratio of the number of tulips to the total number of flowers in Jan's garden? If I wanted to do a part-to-part, so the part-to-part, that's not what it asked me here, but just if I did a part-to-part here, and let's say I wanted to do daffodils to tulips, that would be 15 to 12. You have a common factor of 3 there, so that's a 5 to 4 ratio. But this actually asks for a ratio of the number of tulips to the total number of flowers in Jan's garden. Well, there's 27 total flowers, 15 plus 12. The number of tulips is 12. So this time, again, you have a common factor of 3, so that is a 4 to 9 ratio of tulips to total flowers in the garden. All right, in this next problem we have a ratio of cats to dogs in an animal shelter is 6 to 7, so that's cats to dogs. Let's say there's a total of 91 cats and dogs. How many of each are there? Well, I could first figure out the number of cats, since it's cats to dogs, so that's 6 part cats out of 13 total parts. That's 6 plus 7. As X is my missing amount is to 91. Now what I've done here is I've set up what we call a proportion. I'm going to assume you've had lots of experience with this, but a proportion is when we set up, it's when you set up, setting up two ratios in an equivalent relationship. And there's no point to really doing that unless one of the pieces is missing. And we can use this, since we know the ratio of cats to total, and then we know the total, we can set up the missing piece as being how many cats there would be at a total of 91 if the ratio is 6 to 13. You can solve proportions either by cross multiplying. For example, I can go 6 times, let me just write it right here. So I can say 6 times 91 equals 13x, and then I need to do what 6 times 91 is over here. So that's 546. So 546 equals 13x divided by 13, and that is so there are 4 and there's 26, so there's 42, so x equals 42 cats. And the other way you can do it is you can set this ratio up where I have 6 over 13 as x is to 91, and I can, so from here what I do is I consider what I multiply 13 by to get 91, and that's times 7, so that would be in the same relationship what I multiply 6 by to get x, and so that's another way you can get that 42 cats. And we know the number of dogs has to be 91. We don't have to do all that work, it's just 91 minus 42, since it has to sum to 91, and so that equals 49 dogs. Alright, so let me move this up. So looking at the last problem on this page, if you have Janice and Mickey and Fred split money they received from winning a lottery ticket in the ratio of 5 to 4 to 3, so it's a 3-part ratio. That's just saying that's how they split the lottery money. What if the total was 720? So let's find the piece that's Janice, and that's the 5-part. And Janice, so we can use a part to whole ratio. So 5 is to, if you go 5 plus 4 plus 3, that's 12 parts. So 5 of 12 parts is what Janice got, as x is to 720. And we can think about what kind of multiplier we use here. And so that's going to be times 60. And that's times 60. So Janice got $300. That was her part of the lottery winnings. Let's go to the next page. So this part of the lesson is on rates, and a rate is actually a specific type of ratio in which compares two quantities with entirely different units by division. So, for example, if I have 25 students per 3 teachers, that's an example of a rate. and buy 40 grapefruit for $9. That's also an example of a rate, because the units aren't convertible, aren't the same or aren't convertible. Like I might have 18 inches for 2 feet, and the units are different, but I can make them the same very easily. I can make that 18 inches to 24 inches, and that's a common factor. So that's a ratio of 3 to 4. It's not really a rate because I don't even have units in my answer. I just say that's a ratio of 3 to 4. But here I can't change teachers into students or students into teachers. I can't change grapefruits into dollar. Let's put a little S on the end of there. Most commonly when we use rates, we use what are called unit rates, and that's a rate whereby you have an amount of a quantity per 1 unit of another, and that 1 unit will always be in the denominator. So if I look at that previous ratio of 25 students to 3 teachers, if I want to get 1 unit in the denominator, I've got to divide that by 3. I divide the numerator by the same amount, and I get 8.3 repeating students per 1 teacher, and that's a unit rate, an example of a unit rate. So on this So for this second rate I had up here, I can make that into a unit rate by, I have 40 grapefruit and $9. I want to divide by 9, and that will get me the number of grapefruit I'm getting for $1, and that's 40 ninths. Now 40 ninths is 40 over 9 equals 4 and 4 ninths, and that's going to be like 4.4 repeating grapefruit per $1. Now, if I wanted to do what's called a unit cost is you'd always put the Now, one other thing I want to look at is unit cost. If when I want to do a unit cost, I want to make sure that I have how much something costs per 1 unit of something. So in this case, notice I put the dollars in the numerator. You'd always want the dollars in the numerator for a unit cost. So if here what I'd want to do is I'd have the $9 in the numerator, the 40 grapefruit in the denominator. This time I'd want to divide. I want to get the 1 in the denominator. So that's just 9 divided by 40. 9 divided by 40 is 0.225, so it's like 22.5 cents per grapefruit. That would be the unit cost in that relationship. So that's the idea of rates. Now let's look at some examples. So I'm looking at some rate and unit rate problems. Let's look at this first problem. Is how long would it take to fill a 12,000-gallon swimming pool at a rate of 1,250 gallons every 3 hours? So we're going to use a proportion to solve this one. And again, just some side notes on what a proportion is. A reminder about that. A proportion is when set two ratios equal to each other. And there would really be no point to setting two ratios equal to each other unless one of the four pieces of information was missing. So we're going to use it to solve for an unknown, and we know 3 out of 4 pieces of two ratios that are in an equivalent relationship. So I'm going to say 1,250 gallons is to 3 hours, as 12,000 gallons is to X hours. And I'm going to take the units out now and solve this over here. So 1250 over 3 is 12,000 is to X. I don't see a clear multiplier there, so I'm going to cross multiply here to solve this. So I say 1250X equals 36,000. I'm going to divide each side by 1250, and that would get me. And that equals 28.8 hours. Okay, let's take a look at this next problem. You have a building contractor provides tool belts to her employees. She has 5 heavy-duty belts for $195 at Highland Supply, or she can buy 8 of the same kind of belt at $296 at Building Depot. Which store offers the better unit price? So we just want to find a unit cost for both of those under both of those scenarios. So we're going to put the dollars on top. So in the first one, it's $195 for 5 belts. And the other one is $296. It's $296 for 8 belts. So divide this one by 5. And so 195 divided by 5 is... that is $39 per belt. And this other one I'm going to do divide by the numerator and denominator by 8. So 296 divided by 8 is... that's $37. It's $37 per belt. So that makes this one the better buy. And it then asks, how much will the contractor save on 40 tool belts at the better price? Well, since there's a $2 saving, that would be 40 times 2, or $80 saved. All right. Okay, the last problem in the lesson is if Jan Mark can run 3/5 of a mile in 2 minutes and 30 seconds, what is his rate in miles per minute? So we're going to have to take that 2 minutes and 30 seconds, and we're going to make that into minutes. So that's 2.5 minutes, which we'll call 5/2 minutes. And so he's running 3/5 of a mile and 5/2 minutes. So if I want a unit rate there, I need to divide by 5/2. So 3/5 divided by 5/2 is the same as 3/5 times 2/5. So he is able to do, so his unit rate is 6/25 of a mile per minute. And that's the end of the lesson.